In this video, we are going to discuss about smart textiles. So I am Vinod, Assistant Professor, PC Department. Smart textiles introduce a shift from the passive functionality to active behavior, which will result in the integration of microelectronics in textiles to endow material with new properties. The production of smart textiles is now a reality after a successful marriage of traditional textiles and clothing technology with other branches of science like material science, structural mechanics, sensors and actuator technology, advanced processing technology, communication, artificial technology, artificial intelligence, biology, etc. The definition of smart textiles is a textiles that can sense and react via an active control mechanism to the environment conditions or stimuli from mechanical, thermal, chemical, electrical or magnetic sources. Next, we are going to discuss about classification of smart textiles. The first one is passive smart textiles. It can only sense the environment. Here we are going to use different types of sensors. Next one, active smart textiles. Here it can sense by using a sensors and it will react to the environment stimuli based on the actuators. Third one is ultra smart textiles. Here it can sense, react and adapt themselves to the environment. So it is having a reasoning, cognition and activating capacities. Functions of smart textiles. First one is sensing, second one data processing, third one actuation, fourth one storage, fifth one communication. First, let us discuss about sensing. Basically, sensing is the function of transforming a signal into another signal that can read and understood by a predefined reader, which can be a real device or a person. For real devices, all the signals should be ultimately converted into electrical ones. Thermocouple quantum tunneling composites, which is based on short-switch technology, fiber black grating sensors, basically optical fibers, are used to convert the signals into electrical ones. Second one, data processing. Data processing is one of the components that are required only when active processing is necessary. Problems need to be overcome before imparting textile material for these functions are fastness to washing, deformation, interconnections, etc. So far, pieces of electronics are used for data processing, which are now available in miniaturized and even in flexible forms. Third one, actuation. Actuators respond to an impulsive repulse resulting from sensor function, possibly a data processing. Actuators make things move, release substance, make noise and many more. Shape memory materials, drug supply system, emitting substance are the best suiting examples in this field. Next one, we require storage space, right? So the storage. Sensing, data processing, actuation, and for communication need, they usually need energy, mostly electrical energy. For efficient energy management, there should be an appropriate combination of energy supply and energy storage capacity. Here, some of the energies are instance body heat, mechanical motion, elastic from deformation of the fabrics, kinetic from body motion, radiation, etc. Phase change materials or PCM act as energy storage. Next one, communication. It may be required within one element of a suit. Optical fibers, conductive yarns. So, if it is between the individual elements within the suit, optical fibers and conductive yarns are used. So, if the communication is from the wearer to the suit to pass instruction, then we require optical fibers. Last one, from suit to the wearer or his environment to pass information. Wireless communication, that is, antenna manufactured in textile materials should be used. So next, smart materials which we are using nowadays are thermoregulating materials. Next one, chromic material. Next one, luminescent material. Next one, conductive material. Next one, voltaic materials. Last, electronic textiles. So these kind of materials are used in the smart textiles. So let us discuss about thermoregulating materials. It is nothing but paraffin phase change material, that is PCM in textiles. It acts as a storage of heat in garments. It provides a thermal balance between heat generated by the body while engaging in sports and the heat released into the environment. PCMs are applied either in spinning or during chemical finishing of textiles like coating, lamination, etc. Next one, chromic material. So this will change their color reversibly according to external environment condition. That photochromic, which is external stimulus, is light. Thermochromic, thermo represent heat, right? So the external stimulus is heat. Electrochromic, here the external stimulus is electricity. Next one, physochromic. The external stimulus is pressure. Last one, solvatochromic. Solvatochromic, which is here the external stimulus is solvatochromic. Solvatochromic, external stimulus is liquid or gas. So next material is luminescent materials. Luminescent represent light, right? So it will emit lights according to the external environment condition. So here the subdivisions are photoluminance. First one is external stimulus is light. Next, electroluminance, external stimulus is electricity. Chemioluminescence, external stimulus is chemical reaction. Next one, triboluminescence, external stimulus is friction. So the next one is conductive materials. So the conductive materials I have shown in the right hand side. The function is it will conduct electricity. So their properties are, should be lightweight, flexible, cost competitive with ability to be crimped, soldered and subjected to textile processing. So the preparations are, it can be made by filling synthetic fibers with carbon or metal particles, coating fibers with conductive polymers, or using conductive short fibers. Next one is voltaic material. Here the storage of energy for electronic parts. It uses solar cells. So you can see here, this photovoltaic material possesses the property to generate electric current by means of light excitation. So here the research is going on in order to produce and store electricity from body movements and also from wrist rotation. So the next one is electronic textiles. So these materials with electronic functionality and at the same time it should have a textile characteristics. So you can see in the figures. Okay, so I have given some 3 to 4 examples. So the advantages should be it should be lightweight, durable, washable, integratable with human bodies. So the examples are smart shirts, the sensory baby vest, the recipe belt, and the wearable computers. So the area of research and developments for this smart textiles is currently going on for sensors and actuators are in photosensitive materials and chemical responsive materials and micro and nano materials. For signal transmission, processing and control, the research and developments are going in the area called neural networks and control systems. Next one is cognition theory and systems. For integrated processes and products, it is basically in the area of tissue engineering and then chemical drug release.